Hello students, welcome to the next lecture. Based on your several requests, I start this lecture, that is a function of the several variable, in this video. I myself Dr. Harish Garg. You can simply follow my YouTube channel and you can follow my playlist of the CSIR UGC NET. What is the objective of this lecture? We will cover more than 20 plus questions related to the CSIR NET examinations on the topic function of the several variable. In this lecture, I will discuss only about the continuity of this function of several variable. However, how you can check the differentiability, that we will upload, that you can see in my next video that will be uploaded after this lecture. So in this lecture, I will cover all those functions in which they are asking you check whether the function is continuous or not and their related problems. So before I start with this PY question, let me quickly recall you what is the concept and how you can solve this. Whenever you have the function of the several variable like f of x comma y, or you have more than two variables like x1, x2 and so on, and if whenever they are asking you check whether the function is differentiable or not, you always need to find the limit of this function at the corresponding point. If the limit of this function exists and unique, that is the most important word. If the limit exists and unique, then you can say the function is continuous. On the other hand, if you prove that the function is not continuous, it implies function is not differentiable. So whenever you want to prove that function is not differentiable, you can simply prove function is not continuous. However, if you have the function in the polar form, then you have to take the limit as r goes to the center, that is x naught square plus y naught square. If this limit exists and independent of theta, then only you can say this function is my continuous, otherwise not. Again, if the function is not continuous, then we can say function is not differentiable. Now I can start my PY. Till then you can simply scan and join my WhatsApp group for various discussions. Now let's see how you can solve this question. If you look about this question, for all those points in the R2 where this is a non-zero, theta is the unique real number, that is, this is basically a principal argument. Fine. Then the resulting value of theta will be here. So what is the value of theta? That is my tan inverse y over x. Fine. Then the function is differentiable, continuous or not. We can simply find the limit as x comma y is, what is that, at any point of this. Fine. How you can find? I can simply take the path y is equal to mx. So this value becomes my tan inverse m. Now since for the different value of the m, it has a different value, so which is not, is it unique? It is not unique. So what does it mean? It means limit does not exist. Fine. If the limit does not exist, it means the function is not continuous. If the function is not continuous, it means the function is not differentiable. So we can see function is differentiable, cancel out. Function is continuous is a wrong option. Function is not continuous, that's satisfied. Now it's a bounded. How you can check out the bounded? Again, we can start with the absolute value. What is the absolute value of this? That's a tan inverse y over x. So clearly say the tan inverse is less than of pi by 2. What does it mean? That means this function is my bounded. So the third option said bounded and not continuous, the correct option. Neither the bounded, but it is a bounded option. So C is my right answer of this problem. Look at this another one. Consider the three subset of the R2, A1, A2 and A3. If I draw this graph, this is a circle. This is my A1. A2 is the line. X is my 1. Y is anything. So this is my A2. Fine. A3 is my point of 0, 2. So 0 and this my point is 1. So 0, 2 lies here. This is my A3. Fine. Then there always exists a continuous function f such that f of x is aj, while x is belongs to my a j varies from 1 to. Now clearly says, look at that, what is the intersection of A1 and A3? 5. What is the intersection of A2, A3? Again 5. What is the intersection of A1 and A2, which is only element of this? Fine. So what does it mean? If I consider A is my 1, 0, fine, then definitely what is that? This is my x1. If I consider x is from my here, and if I say x is my of this, so what does it mean? When it will be continuous. For the continuous, we definitely know A1 must be A2. Fine. This must be. Now look at that. If and only if, that's a fine statement. However, what is the A3? If because this is I, what is the A3? Because A3 is my disconnected from A1 and A2. Is a disconnected from A1 and A2. So what does it mean? A3 can have any value. Fine. It may equal to the A1 and A2, but it can have any value. So if and only this is satisfied for all real value, that's wrong, because we must have A1 and A2 are same. A1 and A2 are same, so A3 can have any value. So I can assume A3 as A2, or A3 is not equal to A2. So the major thing is this must be true. So this is the correct option. If and only if at least two of the numbers are equal. If I say at least two of the numbers are equal, so I can assume this and here. Fine, this also satisfies this property, but we must know A1 and A2 must be equal. So it means this option is cancelled. Fine, so if I say at least, I can assume this number are there, but A1 and A2 are not equal. So which is not possible. So answer is my B and D. B and D are my correct options for this problem. Okay, look at this another one. Okay, you have to find S contain of this. Okay, firstly I will tell you the limit tips. Whenever you are finding the limit as x approaches 0, or whenever you are finding the limit as x approaches infinity, this value will be 0 if the degree of numerator is greater than of the degree of denominator, and this value will be 0 if degree of numerator will be less than of the degree of denominator. Fine. And if this value is infinity, if degree of numerator is less than of this, and this value is infinity if it is greater than of this. Now you can see this value is approaches toward the 0 and this value. It means the degree of numerator must be greater than of the degree of denominator. What is the degree of the numerator? Alpha plus beta. Fine. What is the highest degree of the denominator? Because of this root, the degree is 1. So what is the right answer of this? Alpha plus beta must be greater than 1. So C is the right option. Now look at that. If alpha is greater than 0, I can assume alpha is my 0.1, beta is my 0.2. Is it greater than of 1? No. Is it greater than of this? But alpha is my greater than 2. But there is no restriction of the alpha. You may choose alpha is my here and beta is my 1.2. But both the properties are not satisfied here. Similarly, you can't satisfy this option. C is the right answer of this. So simply remember these shortcut tricks. Whenever you have the 0 about here, whenever it's infinity, think about this rule. Okay, consider the function f. f0 is given, g and this. F is continuous, f is not continuous. Okay, we can firstly find the limit as x comma y 0 0 of f. Fine. So clearly say if you take 0 comma 0, it's a 0 by 0 form. So I can take the path as y is equal to mx. So this value will comes my x approaches 0, 1 minus cos 1 plus mx divided by x square. That is my x square I can take as a common and of this. Now what is the limit? X approaches, it's a 0 by 0 form. Now I can apply the L'Hopital rule. So it's a minus sign, it's a 1 plus m into x into 1 plus m. divided by 2x of 1 plus m square. Now if I take as a x0, again it's a 0 by 0 form, so again I can take as 0 by 0, so sine will be my cos 1 plus m into x, and it will be my 1 plus m whole square divided by 2 times m plus here. Now you can see when x is 0, it is my this divided by 2. So what is that? It is not unique. So once, because it depended on the m, it means it is not unique. It means limit not exist. If limit not exist means the function is not continuous at 0, 0, because we find the 0, 0. Function is continuous at 0, 0 is the wrong option. Now check whether the function is continuous at except 0, 0. I can simply choose 1, 0. What is that? What is the function value at 1, 0? So this is when not equal to 0, otherwise here. Fine. The meaning of this is my here, sorry, f, yes, okay. So what is the 1, 0? It value lies at here, and yes, and clearly says once you take the function, what is the value of this? It is my 1, 0. I can substitute it 1 minus cos 1 over 1. Fine. So clearly say this is my continuous function. So this function is not continuous at origin, while all others is my continuous. Similarly, if I look about the g, if I skip this portion, again for the g I can start from here. Again I can take the path of this 1 minus cos 1 minus mx divided by x is common 1 plus m whole square. So again it's a 0 by 0 form, so I can apply the L'Hopital rule. So 1 plus x into 1 plus m divided by 2x of 1 plus m whole square. This value will be cancelled out. Now what is the limit of this as x approaches 0? Again 0 by 0 form, so it is a 1 over 2. And you can see this value is also as a f of g, g of 0, 0. So what does it mean? Limit is exist, and it means limit g is continuous at 0, 0. Is the function is continuous because the only breaking point is my 0, 0. Fine. Or 1, minus 1. If x is 1, y is minus 1. The function is my half. So it is always a constant function, is my continuous. Right answer is B, C and D are my right answer. Okay, look at this one. Firstly, I can assume n is my 1 because it's a Rn. I can simply take R to R so that it will be easy. So this norm, this function becomes my here on a single. Fine. So what does it means? If I divide it by x minus y, it will be my derivative should be greater than or equal to 1. Fine. So what kind of the function? F is on, okay, look at that. So can you choose any of the function whose derivative should be greater than of the 1? So if I choose 2x plus 7, what does it means? You can see what is the derivative of this 2, and it satisfied this property. So but what is the f of 0? 7, which is non-zero. So this option is cancelled. Now f is on to close and open. So this basically I need to prove f of r, and this is again f of r. Okay. Now how you can prove that it's open and close? If I prove f of r is my r, that means if I prove the function is my bijective. Fine. How you can prove the bijective? Cardinality of the domain and cardinality of the codomains are same. If I prove it's a bijective, what does it mean? It means it is open and close both. Fine. Or if I prove it is a 1, 1 and on 2, again it's itself the meaning of this. So how you can think about that? Again very simple. Clearly says since the function f whose derivative should be greater than of the 1, and f is my r to r. So what is the range of the f? Is my unbounded. What is the range of the f? You can see f is R to R. Now also how you can, okay, can you say it's a 1 1? If I assume x is not equal to y, what does it means? X minus y is my greater than 0. If x minus y is greater than 0, so it means fx minus fy is greater than 0. It means fx is not equal to fy. So what is that? It means this is 1 1. If it is 1 1, this is here is onto. So what does it mean? It is my bijective. So once it's a bijective, it's a onto as well. Once it's a bijective, it implies f of r is r. So what does it mean? It has open set to the open, close to the closed subset. So this is A, B, C are the right answers. Okay, for any y is in R, greatest integer of this function is defined as x greatest integer of y. Remember that greatest integer is discontinuous function. Fine. F is a continuous function. Can you say it's a continuous function on every R? So clearly say what is the f of 0 comma 0? It is not defined. Fine. So once it is not defined, it means the function is not continuous even at the point 0 comma 0 because it's a complete R2. Next, for every y, so that means we can fix y, say y is equal to 3. For every y, x is a continuous mapping. So what is the f of x comma y? So x greatest integer is 3, or if you choose y is equal to 1.2, then your fx will be greatest integer of y will be my 1. What is that? This is a polynomial. This is a polynomial. Fine. So what does it mean? It means every polynomial is my continuous function. So that's, yes, it is my continuous apart from the 0 because 0 is not satisfied. For every x, now if you fix the x, if I fix x is say my 3, then y is a continuous function. So what is the value of the y? Y can be anything because it's a greatest integer and greatest integer is my discontinuous. So definitely this function is my discontinuous. Fine. Or if you elaborate that, if I take value of y is my here, so this value will be x0 greatest integer. If I take this value, it will be my x of 1. If I take 2 to 3, it will be here and so on. So if I take x is my 3, first value will be my 1, this value will be my 3, this value will be 9 and so on. So clearly say this function is discontinuous at y is equal to 1. This function is discontinuous at y is equal to 2, or you can simply use this concept. So for every y x, this function is a continuous is the wrong option. F is continuous at no point. That's a wrong option because we already say f is continuous for all points on the R for the fixed value of the y. So this option is cancelled. B is the right answer of the problem. Okay, look at this one. F is a mapping from this. F is defined here. F is a locally invertible. What is the meaning of the invertible? That means derivative should be non-zero, but it's a function of the several variables, so you can define as the Jacobian. Fine. So that means partial derivative of x with respect to this and g with respect to x and g with respect to y. So I consider this is my f, this is my g. So what is the answer of this? What is the f of this? It's a 3x square plus 6 with respect to x. So it is my 3y square minus 50. Fine. And if I take this with respect to y, it's a 6xy minus 12. G with respect to of this. Now what is the derivative? What is the determinant of this? It's a 3x square, 3y square minus 6xy minus 3. So I can take 3 as a common. So x minus y of whole square minus 1. Now what is the S is? Collection of all those pairs such that f is invertible. It means this should be non-zero. So if this should be the non-zero, it means x minus y should be not equal to plus minus 1. So that means x minus y is not equal to plus minus 1. This is my S. Now S is my R2 minus 0, 0. That is not true. Why? What is the x minus y plus minus 1? So this line is my here, or this line is my this. This is my x minus y is equal to 1. This line is y minus x is equal to 1. Fine. So what is that? S is collection of all those. This is my S. This line, this is not equal to, so we can say R2 minus this line, L1 of this. Fine. So but here it is not here. Then whether S is my open or not, so clearly says that this is my open. Why? If I take any of this, if I draw the unit circle, you can easily do that. I can do like here. So S is my open. Is the S is dense? Again, that's again very simple. How you can prove that S is dense in R2? If I choose any value in my R2. Fine. So what does it mean? Either the difference is my plus minus 1, or the difference is not equal to plus minus 1. Fine. If the difference is not equal to plus minus 1, this means this set is in my S. Then this means it is in my S complement. Fine. What does it mean? All the points on the line y is equal to x plus minus 1 are my, what are those? Are nothing but my limit point of the S. So what is the definition of the dense? So it means S is my dense in the R2. R2 minus S is countable. What is that? If I define what is the S is, what is the R2 minus S? So what is the R2 minus S? Is this line. Fine. How many values are there? There are infinitely many values lies on these lines. That means my countable. So this option is uncountable, but is a countable is a wrong option. Right answer is my B and C are the correct options. Okay, look at this another one. Okay, a very beautiful tips I will give you how you can check that. Definitely you can take the path y is equal to mx, but I will tell you the simplest tool. X is equal to a, y is equal to b, x power c plus y raised to power d is continuous if and only if a over c, that is x and x, plus b over d should be greater than 1. This function is said to be continuous if and only if this property hold. I already explained this concept in my PY question series of continuity and differentiability. You can watch my this lecture, that's a GATE 1996 to 2023. You can watch my this lecture for finding the more examples on this concept and the very shortcut tricks of the function of several variables. Anyhow, now you can see how you can check that function is a continuous or not. You can see it's a 1 and 1. So 1 over 2 plus 1 over 2, which is not greater than 1. What does it mean? Function is not continuous. If the function is not continuous, it means the function is not differentiable. But first option said function is continuous at 0, 0, because breaking point is 0, 0. Function is not continuous. How you can check function is differentiable? Function is continuous at 0, 1. So where is the 0, 1 lies? 0, 1 is here. So function is continuous, not continuous at 0, 0 only. So it means this option is my correct option. Whether the double integration or the function is bounded. So how you can check that? Again very simple. Firstly I can check about here. Fine. F dx dy. Since it is difficult to integrate them, you can integrate like of this 0 to 0 xy x square plus y square dx dy. I can integrate with respect to x, y as a constant. So it's a tan inverse y over x over 0 to 1, then it will be my y tan inverse 1 over x minus 0. Value of x is a tan inverse y. Fine. Then again you have to use some byproduct rule, but I will tell you the simplest way. You can change into the polar coordinate. X is r cos, y is r sine. Fine. So this value, that's my x is 0, y is 0. So this value, so what is that domain is? Radius is 0 to 1, angle is 0 to. So what is that? This is my r square cosine. This is my r square. So this is cancel out. I can multiply 2 and divide it by 2. And dx into dy is r dr d theta. So what is the limit? I can take r is r square by 2 over 0 1. Sine will be my minus cos 2 theta divided by 4 from 0 to pi by 2. So it is a 1 over 2, and it's definitely is a finite number. It's a 1 over 2. It is a minus minus plus 1 over 4, which is a finite number. So this is my correct option. Check whether the function is bounded or not. How you can check the function is bounded? Again, I can start with this modulus value, which is xy over x square plus y square. Fine. I can change into the polar coordinates. So this is again sine 2 theta over 2, which is less than of half. So that is the meaning of that. It is my bounded function. So f is a bounded function. This, so b, c and d are my right answers of this problem. Fine. So that's a very simple. You can simplify it in a very simple manner. Look at this next example. Now check whether this function is continuous, whether this g, they are talking about the g and here. Okay. Again, I can written this function as 2 raised to power 1. This is x square plus y square. So what clearly says 1 over 2 plus 1 over 2 is not greater than 1. It means f is not continuous at 0, 0. Fine. What does it mean? If I see here, because they are talking about g is continuous, g is not well defined, g is here. What does it mean? If I subtract g, f is not continuous at 0, 0, it means this function x minus n, y minus n is not continuous at n, n, then only it becomes a 0, 0. What does it mean? If f is not continuous, this function is not continuous at n, n, it means g is not continuous at n, n only. Fine. So what is that? G, so what does it mean? It means g is continuous on r2 minus of n, n. Fine. Or k, k. So it means this is well. So g is not well defined. Again, this is cancelled. G is continuous from r2 to r. It's again a cancel because it is not continuous at r2 point. So this is cancelled. Now check whether the h of y, which is g of cy. What is the h of y? G of cy. G is my here. X is my c. So it is my f of c minus n and y minus n divided by 2 raised to power n. Fine. Now since the function is not continuous only at the n, but it is not n. Now how you can check whether it's a continuous or not? Again very simple. We will see whether f is bounded or not. Fine. So clearly say if I start with this value, what is the polar coordinate of this? So it's a 2 sine theta cos theta, and its r square will be cancelled out. So clearly say this number is less than 1. Why? Because it is nothing but sine of 2 theta, which is less than 1. It means f is bounded. If I start from here, what is that? This is less than of 1 over 2 raised to power n, which is that gp. So this sum is my always a finite. What does it mean? If I say this is my bounded, so it means h is my bounded because it's a series, because it is given as a series. So what does it mean? you can say by WM test, this H is my uniform continuous. Once H is my uniform continuous, what does it mean? H is my continuous. So again he said is a continuous on R for all X is the right option. So A and D are my correct options. Whenever there is a question related to this, always check about the bounded and the continuity. Always. Okay, look at this one. Again, check whether the function is continuous or not. I can return this number as x cube y0 divided by x square plus y square. So look at that. 3 over 2 x and x plus 0 over 2. Is it greater than 1? Yes. It means the f is my continuous. Fine. Or other way, you can choose y is equal to mx. Fine. And then you can find the limit as x approaches 0. What is that? It is my x cube. X square will be common, 1 plus m square. So limit will goes to the 0. So function is continuous. Okay, anyhow, but I will tell you this is the best way you can check about here. Is the function is bounded? We can see if I start from mod, it is my x cube over x square plus y square, which is I can written as x into x square over x square plus y square. So clearly say this number is my less than 1. So it is less than of mod x, less than or equal to 1. But what is the domain of the, what is the x? This is my unbounded. Fine. So it means the f is my unbounded. Fine. Or you can check out in the polar form. So this is my r cube cos cube divided by r square, which is r cos cube. So cos cube is a less than of r, and again because it is r, it is my unbounded. So function is my continuous. Function is discontinuous here. Function is continuous. Right answer. Now they are talking about the derivatives. Although I will explain this derivative in my next lecture, but now since this is the question, so I will explain you how you can do that. It's a direction. Okay, firstly, if you prove the function is differentiable, fine, then it implies f has all directional derivative exist. If f is differentiable, but converse is not true. So if I prove the function is differentiable, then this option is satisfied. So how you can prove that function is differentiable? I can start with limit of say h comma k minus a times f, sorry, if I use this is my h and k, h minus k times fy divided by h square plus k square. Fine, this is the rule for that. H comma k is my 0 comma. My target is to check whether the limit exists or not. What is the h? What is the fx is? Partial derivative with respect to here. So I can use the definition. Limit x approaches 0, x comma 0 minus 0 comma 0. So what is the answer of this? Ux comma 0. This value will be 0. It's a x. 0 comma 0 is a 0 divided by x. So this value is my 1. So this is my 1. Similarly, fy is limit y approaches 0, 0 comma y, 0 comma 0 over y. So 0 comma 0 is my 0. So this is my 0. So this is x is h cube divided by h square plus k square minus is a 1 minus h minus 0 divided by root of this. If I take the LCM, is a h k square divided by root of h square plus k square into h square plus k square. So I can take it as a 3 by 2. H square plus k square of 3 over 2. Now can you take the path? How you can prove that whether the limit exists or not? A simple, you can simply take the path is k is equal to mh. Fine. So what is the limit of this when you take k is equal to mh? Otherwise, again, what is the degree of the numerator? Degree of the numerator is my 3. What is the degree of the denominator? It's a square, it's a 3 by 2. It's again a 3. Fine? It's a 3. Now they are same. So what does it mean? It goes to the 0. Otherwise, there is no need. I will take the path h, MOH. This is h square will be common. 1 plus m square power 3 over 2. So what is that? It's a h cube, and h cube will be cancelled out. It's a m square over 1 plus m square of 3 by 2. What does it mean? Is the function is differentiable? The function is not differentiable because the limit is not exist. It means the function, this limit not exist. It means the function is not differentiable. Fine. Now function is not differentiable. Now how you can check about whether the directional derivative exists or not? If the function is differentiable, then you can easily see. Now directional derivative. So I can check about is a 0, 0. So it's a h of say any vector u1, h of k1 minus h of I call as a k. Fine. Divided by limit of h of this. Now what is the answer of this? What is the h of, no, sorry, this is h. So I can write for you here limit f is a 0, 0. So 0 plus h of u1, 0 plus h of u2 minus 0, 0 divided by h. Take the limit as 0, where u1 and u2 are my direction. What is the h of u1? I can substitute here. First value is my h cube, u1 cube divided by h square is common, u1 square plus u2 square minus 0 is 0 into h. This will be cancelled out. u1 cube over u1 square plus u2 square. This is my existence. So all the direction derivative exists is the correct option. B, C, D are my right answer for. Is u1 and u2 are my direction. Fine. So that is, this is along the x-axis, this is along the y-axis. Okay, look at this, whether the function is, now you can see it is not in the form of x raised to power a into y raised to power a. It's a plus minus. I can take the path y is equal to mx. So this value will becomes my 1 minus m square, 1 plus m square. What does it mean? Limit is not exist, because for the different value it means the function is not continuous. It means the function is not differentiable. So function is continuous at origin. This is cancelled out. Function is bounded. Function is not bounded. Okay, now you can check about the bounded. So that means x square minus y square over here. Now change into the polar coordinates. So the numerator part becomes my this sine square. Denominator becomes my r square. So what is that? R square will be cancelled out. This value becomes my cos 2 theta, which is less than or equal to 1. So that means f is bounded for all those pairs of the x and y. So f is bounded here. F is not bounded, cancel. Now you can see whether all the direction derivative exists or not. Again, how you can check about the direction derivative? Again, I can take the limit f of at 0, 0, 0 plus h u1, 0 plus h u2 minus f of 0, 0 divided by h. Because the function is not continuous, it means it is not differentiable. If the function is not differentiable, then always use this definition. Okay, so what is that? Limit h, so h, if I substitute here, h square will be common, u1 square minus u2 square, h0, 0 is 0, divided by h square is common, u1 square plus u2 square into h will be my here. So what is the limit of this? H approaches 0, it will goes to the infinity. So what does it mean? The limit is not exist. If limit is not exist, it means the directional derivative not exist. So function has all the directional derivative is the wrong option. Right option is only B is my right answer. Okay, look at this one. F is my given to be here. Then okay, F dash, I can found the F dash. It is my minus sine t and cos t. So if I start from here, what is the F dash? Minus sine of t naught cos of t naught, which is 1 over pi. What is the F of 2 pi? So cos of 2 pi is my 1, sine of 2 pi is 0. So it's a 1 comma. And what is the F of pi? It is my minus 1, 0. If I subtract them, it will be my 2 comma 0. Fine. So what does it mean? It means minus sine t naught will be my 2 over pi and cos of t naught will be my 0. So what is the question? There exists. Can you find any of t which satisfy both the conditions? You are unable to find any of the t which satisfy both the condition. It means this option is cancelled. Look at this option. This is the same option. He said there does not exist. That's the correct option because there does not exist any of the t naught which satisfy both the conditions. So it means this option is correct. This is wrong option. There exists t naught such that of this. I can start from here. What is the F? If you subtract them, it will be my 2 comma 0. Norm of 2 comma 0 is less than of pi and norm of minus sine and cos of this. So what is the norm of this? I can say it's a 2. What is the norm of this? Is a root of cos square plus sine square is 1. Does it satisfy? 2 is less than of this. Yes, there exists a t naught which belongs to this, which satisfied this property. F dash of t will be, you can see F dash of t is my area. So the right answers are B, C and D are my correct answers for this problem. Okay, F is a mapping which is defined here for which open set F admit an inverse. Inverse means derivative should be non-zero, but it has a 2 dimension, so we can find the Jacobian. So F, if I consider this is my F, this is my G, so F with respect to R, F with respect to theta, G with respect to R, G with respect to theta. Or otherwise, what is that? This is the Jacobian and this is a standard transformation. So we always know whenever you transform dx dy to dr d theta, we always know this is nothing but R. Anyhow, I can find for you here is a cos and F with respect to theta is my minus R sine. G with respect to R and G with respect to theta. So what is that? It's a R cos square sine square is my 1. So what is that? It is because we need in the terms of x square plus y square. So what is the meaning of that? In order to existence of the inverse, we must x square plus y square should be non-zero. Fine. Now look at that. This option is cancelled out because this is my complete R2 and origin satisfied. What is the meaning of that? X is strictly greater than 0. Fine. And y is strictly greater than 0. So the sum of the square will never be 0. Is fine. This is x square plus y square is less than 0. But what is the less than of 1? It means 0 comma 0 origin satisfied this property. This is cancelled. X will be minus 1, less than of minus 1. Here y is less than of minus 1. So clearly say x is 0, y is equal to 0, not satisfied this. So this option is also satisfied. The right answers are B and D are my correct option for this problem. Look at this next one. F is the mapping from S to S. Fk is the composition mapping. F1 and F2 are here. Okay, we need F1 composition, F2 composition. What is the F1 composition of K? What is the F1 circle F1? It's F1 of x plus 1, y plus 3. It means x plus 1 plus and y plus 3 plus 3 6. So I can write in journal this is 1 times k and y plus 3k. Fine. Similarly, what is the composition of 2? X minus 3k, y minus 2k. Now look at the option. For any positive integer k, there exists a comma b such that f1 0 comma 0. What is f1 0 comma 0? K and 3k. It must be same of f2 a minus 3k b minus. So can you find the value of a from here? A will be my 4k, b will be my 5k. So yes, for every k you can find a and b. So that means this is the correct option. Look at the second option. For any real number alpha and any positive integer k, any positive integer, there exists at most one solution such that this equation satisfied. 0 comma 0 is here, alpha comma y. So this is alpha here and y minus 2k. So your target is to find the value of at most one y. Can you find the value of y from here? This is 5k. 2 plus 3 is 5. Yes, you can find the at most one value. So this is also the correct option. There exists a comma b such that they are not equal for any pair. What is that? It's a plus k and b plus 3k is not equal to x minus 3k, y minus 2k. So there exists a comma b such that they are not equal. Can you find the value of, you clearly says that they are equal. If you choose x, what I can choose x so that it becomes my here, or what I can choose a so that it becomes x minus 3k. If I choose x minus x, a is my x minus 4k, they are equal. What I can choose b, b should be y minus 5k, therefore there exist, but he said they are not equal to, so this option is cancelled. f1 is my linear transformation. What is the meaning of the linear is? Origin must satisfied. f1 0 comma 0, 1 comma 3, which is not 0, it is not linear. So a and b are my satisfied answers. Okay, look at this another one. Which of the following function is the inverse? Again, we have to find the Jacobian. So if I consider this is my f, this is my g, partial with respect to x, 3x square minus 2. With respect to y, x cube plus 1. This with respect to x and this with respect to y. Fine. So what is that? And for p, so p is my 1 comma 0. Fine. So what is the value at x 1 comma 0? E raised power 0 1, it's a 3 minus 2 1. E raised power 0 1, 1 plus 1 2. This is 0, it's a 2, and this is my 2. What is that? 2 minus 4, which is non-zero. Yes, existence, because Jacobian is a non-zero, it means inverse exists. Again from here, if you find the Jacobian, it will be my r, and r is my 1, which is non-zero. Now for this, because there is only single variable, so instead of the Jacobian you have to find the derivative. So it's a 1 plus 4x sine 1 over x plus 2x square cos 1 over x minus 1 over x square. This value will be cancelled out. So it is a 1 plus 4x sine 1 over x minus 2 cos 1 over x. This is my here. Now what is the point is 0. What is my f dash 0? This is my 0, and this is my any number which are lies between 0 minus 1 to 1. So if you choose any number which lies between minus 1 to 1, I assume it is my half. Then you can say this number will be 0. If I choose any number apart from half, then this number is my non-zero. Fine. So what does it mean? The inverse not always exists. So this option is because it's an open neighborhood of 0. So I can choose any of the neighborhood which consists of half is my point. So there is not existence. Look at the last option. If I found, again it's a single variable, if I found the derivative, it's a 2x sine 1 over x and minus cos 1 over x. Can you say, and the point is my 0. What is the f dash 0? This value is 0. So this number is my minus cos 1 over x. Can you say this number is always non-zero? No, it is not possible, because this number may be 0 or may not be 0. So what does it mean? It means this function is not exist, because it consists of values between -1 to +1. So if I choose a value of the x to be which is near to the 0, like when it will be 0, when it will be the pi by 2. So if I choose x to be 2 over pi, then it will be my 0. Fine. So it means for this case it will not be satisfied. Hence the right answers are A and B are my correct options. Moreover, if I choose any of these values as my, say, x is, if I look about, yes, I can choose, if I write here is my n also, then again there is no problem. Fine. For the different, because as this will goes to the 0 as n approaches infinity at the point 0. Okay, look at this one. Consider the function. There is no, you have to find continuous function of this. Now what is the x of gx? This is 0. Fine. What is the x of this is x square minus gx of q. What is the g of x is? G of x is my x raised to power 2 over 3. There is no continuous real value function g on any interval of r containing 0. But you can see this is a continuous function. Fine. So but he said there is no. This option cancel. There exists one continuous function, is a continuous function, right option. There is exactly one differentiable function g. What is the g dash? 2 over 3 x raised to power minus 1 over 3. There is exactly one differentiable function on the interval containing 0. So what is the g dash of 0? Not defined, because it's an infinity, it does not exist. So it means the function is not differentiable on any interval which belongs to the I. So it containing I cancel. There exist two distinct functions, differentiable function which contains 0, but the function is not differentiable which contains here. So the right answer is only B is my correct answer for this problem. So this is the way you can solve all these several function of the several variables here. We will see the next lecture on the function of several variable related to the differentiability. Till then you can simply scan and join my WhatsApp group, like, share and comments on my videos. Best of luck students. Happy learning.